Hello. Today we're going to talk about linear inequalities. So I'm going to start with something we know very well, just a plain linear equation. If I were to graph this, remember, start with the plus 1, rise one spot, and then look at your slope, which in this case would be a 1. So rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. And then we figure out, okay, there's our line. So then I can just graph a solid line through all those points. Okay? I kind of missed. There we go. There we go. Okay, so now, what changes? Well, what is this line really? This line is really a list of all kinds of points that if I plug in the x spot will equal the y. So if I plug in a 0 in the x spot, 0 plus 1 equals 1. So the point that works would be 0, 1. Okay? If I plugged in a 2 or a 1 in the x spot, 1 plus 1, that would equal 2. So 1, 2 works. And basically, they all list out a whole lot of points. And this line is a list of points that satisfy the equation. Okay, so what we're going to do now is take something very similar to that, but change the equal sign into an inequality sign. Now, an inequality sign, the options, there's a whole lot more x's that works for a y. So if I had what things can be bigger than y, so if I chose y to be a 1, now my x could be a 0 plus 1, that would satisfy it, but it could be a 1 plus 1, and that would also be bigger than 1. It could be a 2 plus 1, that is also bigger than 1. 3 plus 1, 4 plus 1, 5 plus 1, there's so many more points that it could work. So what we're going to end up doing is not just drawing a line, but drawing a line and shading it. I'm going to shade a side. So what we're going to look for are, okay, do the points on the line work? Does this 0, 1 point actually work? 0 plus 1 is 1. Is 1 really smaller than 1? No, 1 is equal to 1. So technically, the points on the line don't work. So if they're an inequality sign, and it's just simply smaller than or greater than, then the points on the line won't work. Everything else next to it will, but not those. So we can still draw the boundary, draw the line. We know we're going up 1. We know our slope is 1, so rise 1, run 1, rise 1, run 1, rise 1, run 1. But instead of drawing a solid line, to show that they don't work, we're going to draw a dotted line through these points. So instead of a solid line, it'll be a dotted line, because technically the lines on the boundary don't work. Now, if we had a smaller than or equal to sign, now it would be solid, because then all those points will work. But without it, it's going to be a dotted line. Well, if I want to graph these points, which I had shown over here, where y was 1 every single time, and we said it went up, 1, 1, 2, 1, 3, 1. So 1, 1, 2, 1, 3, 1. All those points work. We can shade, if that's that side of the line. Notice they're all on the same side of the line. We can shade that side of the line. If we want to try seeing if this point, I'm going to pick a point on the other side. I'm going to pick this point, negative 2, 2. If I plug in a negative 2, 2, is that going to be smaller? Will that work? Negative 2 plus 1 is a negative 1. Is negative 1 bigger than a positive 2? Well, no. So that point does not work. We do not want to shade that side. Okay, so the blue points all work because they work on that side of the line they shaded. Anything on the other side of the line won't work in that equation. Okay, so let's get to your assignment. What types of problems are you going to have? Okay, graph this equation. Real quick. Start with your y-intercept, plus 3. 1, 2, 3. Go to your slope, 2 over 1. Rise 1, 2, run 1. Rise 1, 2, run 1. Down 2, backwards 1, okay? Then, look at, does it need to be a solid line or dotted line? If there's an equal bar under it, it's solid. If there's not an equal bar, like in this case, then we're going to make it a dotted line. So let's make this a dotted line. Okay, dotted line. Then we need to pick a point and figure out which side of the boundary do we need to shade. So I'm going to pick, my favorite point to pick is 0, 0. So let's put a 0 in the x spot, and let's put a 0 in the y spot. Is 0 smaller than 2 times 0 plus 3? Well, 2 times 0 is 0, so we're just going to be left with a 3 is greater than 0. Is that true? Yes, it is. 3 is definitely bigger than 0, and 0 is definitely smaller than 3. So this point that I picked, 0, 0, is on the side that works. So we're going to shade every single point on that side. Had this not worked, had I got something the other way around, then I wouldn't have to try another point. I could just simply know that it's the other side that works and shade the other side. So you shade the side of the points that work. If you're given something like this, you can graph it in standard form. That's fine. Some people might prefer to say, hey, I'd rather change this into slope-intercept form. And that's OK, too. So let's minus 3x to both sides. Minus 3x to both sides leaves a minus 5y is smaller than or equal to minus 3x plus 10. And then divide by minus 5. Divide by minus 5. Divide by minus 5. Now, real important. When you divide by or multiply by a negative, that sign switches. So we'll have y is greater than or equal to 3/5 x minus 2. So if you multiply or divide by a positive, it stays the same direction. But if you multiply or divide by a negative, you have to flip the sign. Now you can graph it in your slope-intercept, which is nice and handy. So we'll go minus 2, so down 2. Rise 3, run 5. So rise 1, 2, 3, run 1, 2, 3, 4, 5. Rise 1, 2, 3, 1, 2, 3, 4, 5. We're going to be off the grid a little bit. Next, look at your line. Does it need a solid or dotted? If there's a bar under it, it's solid. So in this case, we can just draw a solid line. Last step, pick a point. My favorite is 0, 0. Now, if 0, 0 is on the line, you can't use it. In this case, we can still use 0, 0. Plug in a 0 for x and a 0 for y. Is 0 greater than or equal to 3/5, which is 0, times 0, minus 2, so that's just a minus 2. Is 0 bigger than or equal to minus 2? And in this case, yeah, 0 is bigger than a negative. So yes, 0, 0 is on the side of the line that you want to shade. We'll shade that side. Now, what if there is missing a variable? Well, y is smaller than or equal to 2. Well, remember, in a table with an x and a y, your line is going to be where y equals 2. So every point has to be a 2. So x can be a 1, a 2, a 3, a 4. It doesn't matter. X can be over 1 up to, 2 up to, 3 up to, 4 up to. And you can see how it's going to be a horizontal line. Check your sign. Solid or dotted? There's a bar there. So that means it's going to be a solid line. Shading, are we shading above it or below it? Pick a point. Try 0, 0. Now in this case, there isn't a spot to put the x. All we have is the y spot, so that's all you use. Is 0 smaller than or equal to 2? Yes, it is. So we shade that side. So this whole side gets shaded. What if I have an x is greater than -1? Okay, well, remember, the line is going to be where x equals -1. -1, -1. Everything's going to be -1. Y can be 1, y could be 2, y could be -3. It doesn't matter. So x is -1, we're going up 1. -1, up 2. -1, -3. You can see the line. Double check, is solid line or dotted line? There's no bar under there, so we're going to dot this line. Now, pick your favorite point. 0, 0. Doesn't have a y spot to put it, so let's just put in a 0 in the x spot. Is 0 greater than -1? And again, yes it is, so we'll shade that side of the line. Now remember, if you get something that doesn't work, where 0, 0 doesn't satisfy it, then you shade the other side. Okay, what if they give you words? Suppose your budget for a party allows you to spend no more than $12 on peanuts and cashews. Peanuts cost $2 a pound, and cashews cost $4 a pound. Find 3 possible combinations of peanuts and cashews you can buy. So write an equation. The cost of peanuts plus the cost of cashews has to be less than or equal to the total budget. So let's let x be the number of pounds of peanuts. So peanuts cost $2 a pound, so we're going to go $2 a pound times our x plus cost of cashews cost $4 a pound. So $4 times however many pounds of cashews we're going to buy. And then that's going to equal how much, or less than, could be equal, but it better be less than or equal to how much money we have. They're telling us $12. So now they're asking to find 3 points that will be smaller than 12. In this case, we can just pick some points that times 2 will be 12, will be smaller than 12. Otherwise, we could graph this and then pick points off of a graph as well. I'm going to graph it so we can see it. So if I'm going to graph where's my y-intercepts, put a 0 in the x spot, you're left with 4y equals 12, or is less than 12. Divide by 4, you get y has to be less than or equal to 3, so there's 1 point. Put in a 0 in the other point, you'll have 2x equals 12. Divide by 2, x equals 6, or is less than or equal to 6. So 0 left and right, up 1, 2, 3. Over 1, 2, 3, 4, 5, 6, up and down 0. And I'll graph my line. Now remember, in this case, because we're buying cashews and peanuts, negatives don't make any sense. So really, we're just looking in the positive realm here. So now, we got to keep that under. We got to keep y lower than 3 if x is 0. Okay? We got to keep x smaller than 6. It's under 0. So we're looking for points in here. I can pick this point here. That'll work. This point here. That'll work. This point here. And this point here. And I don't want to pick any zeros because we need a combination of peanuts and cashews. So I could say a few options that would work would be 1 pound of peanuts and 1 pound of cashews. 1 pound of peanuts and 2 pounds of cashews. 2 pounds of peanuts, 1 pound of cashews, or 3 pounds of peanuts, 1 pound of cashews. And so all those points would work in this situation. If this helps, good luck.